Question 1. Question 1 says that there is a multiple choice question on a test in which there are 7 possible answers. Let's say, for example, that E is the correct answer. What that means is the rest of the answers will be incorrect or not correct. So that the probability then of guessing a correct answer will be the number of correct answers out of the total number of answers. And we'll see that there is one correct answer out of the 7 answers. We use the definition of probability. Question 3. The probability of someone being born in May when we ignore leap years. Now, there's 365 days in a non-leap year. Compared to 360 days in a leap year. So the probability that someone is born in May is the number of days in May out of the total number of possible days in a year. So if we ignore leap year, we are saying that there are 365 days in a year, while we know that there is 31 days in May. So that the probability of a person being born in May is 31 over 365. Question 5. Question 5 is a survey or a poll. In this survey, 127 people have responded that they have been in a car accident, while 299 people have indicated that they have not been in a car accident. If we add these values, we can determine that 426 people were in the poll or were surveyed. They want to know, if you select a person at random, what's the probability that the person has been in a car accident? That is found by determining the number of people who have been in a car accident, which is 127, divided by the total number of people that were in the survey. (127) over 426. What we see is that if we approximate this number to the nearest thousandths, the 8 is in the thousandths position. The digit to the right is a 1. That means we leave the 8 alone. So the answer is 0.298. And that is approximate. Number 7. In a town, 25% commute by bicycle. "25% means 25 out of 100. So, what that means is 25 commute by bike, while the difference does not commute by bike. And what I mean by the difference is, of the 100 minus the 25, we find that 75 do not compute by bike. In question 7, they want to know, what's the odds against finding somebody who commutes by bike? The definition is the number who do not commute by bike to the number that do commute by bike. So we're going to find that 75 do not, while 25 do. So this is 75 to 25, or 75 colon 25. Let's go back. 25 commute by bike. 75 do not. The number that do not, 75 to the number that do, is 25. If we can simplify this by dividing both sides, and we can, by 25, we find that the ratio is 3 to 1. 3 people do not commute by bike to every 1 person that does commute by bike. This is the odds against. Question 9. They want us to find the probability of the complement of some event called A, and we use the complement rule, which is 1 minus the probability of A. They give us the probability of A being 20 over 21. So we're going to subtract this fraction from the number 1. But we only know how to subtract like fractions. So we're going to replace the 1 with 21 over 21, which is equivalent to the number 1. And now we have the same denominator, so we can simply perform the arithmetic and find that this probability is 1 over 21. Question 11. Question 11 says that the probability that it will snow in a town on January 1st is 0.455. They're asking to determine the probability that it will not snow on that town on that particular day. We will use the complement rule. 1 minus 0.455 is a probability that it will snow. So 1 minus 0.55 is a probability it will not snow. By the complement rule, we find the answer to be 0.545. Question 13. The probability that someone is not born in May by the complement rule is 1 minus the probability that someone is born in May. In a previous problem, we computed the probability that a person is born in May to be 31 over 365. Now in this question, they indicated to consider that this setting is in a non-leap year. And this is why it's 365 days in a year. So this is a non-leap year question. Replacing 1 with 365 over 365, we are now able to subtract our fractions. Those 365 minus my 31, I get 4, 3, 3. This number divided by the 365 is the probability that someone is not born in May. Question 15. They want to know the probability of being a man or being a heavy smoker when you select a person from this table. By the addition rule, since this is an OR question, we need to compute the probability of being a man and add it with the probability of being a heavy smoker and subtract the probability of being a man and a heavy smoker. I refer to this event as being both. Using the definitions, I need to know the number of men that are in the table divided by the total number of people in the table, the number of heavy smokers in this table divided by the total number of people in the table, and the number of people that are both men and heavy smokers in the table divided by the total number of people in the table. Now, they tell us that 1,046 people are in this table. This will be our denominator for each probability. We have to determine the number of men, the number of heavy smokers, and the number that are both men and heavy smokers. And looking at this table, we will see that there's a total of 485 men in this table. And if we look at the heavy smoker column, there are 87 heavy smokers. So the first row total is the number of men, and this fourth column total is the number of heavy smokers. There's 87. We now have to determine the number who are both men and heavy smokers. And we see that the first row in blue here represents men, and the fourth column here represents the heavy smokers, so that there's 37 people who are both men and heavy smokers. Performing our arithmetic, since they are like fractions, we simply add and subtract the values that are in the numerator positions. We get 535 divided by the 1046. And we're going to approximate this fraction, or the decimal here, to the nearest thousandths. And we see the second one is in the thousandths position. The digit to the right is a 4, so we did not change this one. The answer is 0.511. Question 17. Question 17 is a question in regards to people who are answering yes and no on a survey, and by their gender, either being male or female. So when we say 68 people answered yes, in which 12 were male, that implies that 68 minus 12, which is 6, 5, 56 were female. The next statement that says 87 people answered no, in which 8 were male. Doing the arithmetic, in which we're going to take 87 and we are going to subtract 8, we get 79 were female. Now the question that they're asking here is, what's the probability that a person will answer yes or was a male? This is an OR question, so by the addition rule, it's the probability of answering yes plus the probability of being a male minus the probability of being both. I need to know the number who answer yes out of the total plus the number of men out of the total minus the number who are both men and answered yes out of that total. In 17 here, I have summarized the information that I found in the table. 68 people were asked, 12 answered yes, 87 people said no, 8 were men, so 79 here were female. Let's double check. And so now, if we notice that the total men, which is 20, plus the total females, which is 135, we take the males, 20, females are 135, and we get a total of 155. There are 155 people in this table. This is 155. We have to determine the number who have answered yes, the number of men, and the number who are both. How many yes? The blue column here are all the yes responses, and there are 68 people who have answered yes. The males are the blue highlighted row, this first row, and they are 20 males. So there's 68 yes answers and 20 male answers. We now need to determine the number that are both. The first row in blue here is the male row, and the first column here in blue is a yes column. We will see that there are 12 men who answered yes. 12 people are both men and yes responders. Performing arithmetic here with my like fractions. I get 76. That is 76 out of 155 are either yes or male. If I approximate this to the nearest thousandths, the 0 is in the thousandths position. The digit to the right is a 3, so I do not change that 0. The answer is 0.490, or simply 0.49. Question 19. Question 19 is asking if you select a person at random, find the probability of getting someone who is age 18 to 22 or does not smoke. Probability: person is 18 to 22 or does not smoke. This is an OR question, and so we use the addition rule. Probability of being 18 to 22 plus the probability of not smoking minus the probability of being both. In question 19, what I have done is I have organized the data and the information that was given in terms of a table. So, of 18 to 22 people, we have 177. 23 to 30 years olds, we have 134. 31 to 40-year-olds, we have 311, for a total of 397 people in this table. Or we can answer this question, we can add the number of smokers plus the number of non-smokers, and that will give us also 397. So I have organized the information in question 19 by what was given. Age categories with the smoking numbers and the non-smoking numbers. We have to determine the number who are 18 to 22 and the number who do not smoke. The first row, highlighted in blue, will give us information that 43 smoke, 134 do not, for a total of 177 people in this particular age category of being 18 to 22. This is 177. We need the number who do not smoke. The column highlighted in blue labeled not smoke has 134 people in 18 to 22 age category, 104 in the 23 to 30, 57 in the 31 to 40, for a total of 295 people who simply do not smoke. We need to find now the number of people who are both. We take the 18 to 22 row with the non-smoking column and find in the intersection people who satisfy both criteria of being 18 to 22 and non-smokers. There are 134 such people. Performing the arithmetic with our like fractions, we simply do the arithmetic of the numerators. We find that there is 338 when we add and subtract these particular values. 338 divided by 397. Will be approximately 851 if we approximate this answer to the nearest thousandths. The digit in the thousandths position is a 1. The digit to the right is a 3, which means we unchange this 1. Question 21. 21 is asking the question, find the probability of someone who carpools or someone who works full-time. This is an OR question, so we are going to use the addition rule. We need the probability of someone who carpools minus the probability of someone who's full-time. I should say plus that probability minus the probability of someone who is both. Being both means you are a carpooler and you are full-time. I have organized question 21 in terms of a spreadsheet where we have full-time people in which there's 52 of them. We have part-time people, in which there's 48, for a total of 100 people in this table. So the denominator here is 100. I need to know the number of people who carpool and the number of people who are full-time. If I take a look at the last column in blue here, I have 9 people who are full-time who carpool and 9 people who are part-time who carpool, for a total of 18 people who carpool. I need the number of full-time people. The first row in blue here gives me 9 who use public transportation, 3 who bike, 31 who drive alone, and 9 who carpool, for a total of 52 full-time people. I need to know the number that are both carpoolers and full-timers. If I look at the blue row that represents the full-timers and the carpool blue column that represents the carpoolers, we find the value 9 in the intersection, or we say 9 people are both full-timers and carpoolers. So again, we have like fractions in which we perform the arithmetic in the numerators. We get 61 divided by 100, which will be 0.61. (23) A standard deck. They want to know, in 23, probability of drawing an ace or a 9. This is an OR question. We use the addition rule, which is the probability of selecting an ace plus the probability of selecting a 9 minus the probability of both. Now, the probability of selecting an ace, there are 4 aces out of 52 cards. The probability of selecting 9, there are 4 nines out of 52 cards. The probability of selecting both means that your selected card has to be an ace and a 9 at the same time. You're selecting one card, a card, and they are 0 that satisfy that requirement. 0 cards in the deck are both aces and 9s at the same time. So that's 0 over 52. This probability is simply 0. It's impossible to select a card that's an ace and a 9 at the same time. So we get 8 over 52, which reduces to 4 over 26, which reduces to 2 over 13. (25). 25. We are back to the smoking question. We have men and women who are different types of smokers. Question 25 gives us a table, and they want to know, if we select someone at random, what's the probability they are a regular smoker or a heavy smoker. This is an OR question, and we use the addition rule. So the probability you are a regular smoker plus the probability you are a heavy smoker minus the probability you are both a regular and heavy smoker. We're going to have to apply the definition of probabilities. So we need to know the number of regular smokers out of the total plus the number of heavy smokers out of the total minus the number who are both out of the total. Table 25 is summarized here. In this table, we shall see that there's 475 men, 482 women, for a total of 957 people. There are 957 people in this table. (957) will be our denominator for each probability. We need the number of people who are regular smokers, and we see that by the third column highlighted in blue. 80 men were regular smokers, 60 women were regular smokers, for a total of 140 regular smokers. We now need the number of heavy smokers. The last column, highlighted in blue, is the heavy smoker column. 31 men were heavy smokers, 45 women were heavy smokers, for a total of 76 people who are heavy smokers. We now need to know how many people are both heavy and regular smokers. Now, you can't be both a heavy and a regular smoker, or both a regular and heavy smoker. You're either one or the other, but not both. And by the table, we see that these two columns here, regular smoker and heavy smoker, never intersect one another. They're columns. Rows intercept columns. Two rows do not intersect each other. So this probability is 0, and we're going to add 140 with 76. We are adding like fractions. 140 plus 76. (140) plus 76 out of the total of 957, and we get 216 out of the 957. Numerically, when we divide by 957, we get a number, and if we approximate to the nearest thousandths, the digit here, the 5, is in the thousandths position. The digit to the right is a 7, which means add 1 to 5 and make that a 6. So the answer is going to be 0.226. Number 27 is a marble question. You have a bag of marbles, and in this bag, 7 are red, 4 are blue, 1 is green, and they want to know the probability of selecting a non-blue marble. So we use the complement rule because it's a non-event situation. Probability of selecting a non-blue marble is 1 minus the probability of selecting a blue marble. Now we need to know the total here of marbles that are in this bag. 7 red, 4 blue, and 1 green means we have 12 marbles in this bag. So the probability of a non-blue marble is 1 minus 1 minus the number of blue marbles in the bag over the total number of marbles. We need to know how many of the 12 marbles in the bag are blue. We know that 4 out of the 12 are blue, and we subtract 4/12 from 1, which means we have to change the 1 to 12 over 12, and we find that we get 8 over 12, which reduces to 2/3. This is the probability of selecting a non-blue marble. Question 29. Question 29 is a conditional probability. They want to know the probability of selecting a person who is over 40, given that they drink root beer. In order to answer this question, you need to use the conditional probability definition. So, we need to know of the people in this table that's given here, how many are root beer drinking people? And of these people, we need to know how many are over 40. "29 has the table listed here. The second column we're looking at here is a root beer column. 25 are under 21, 20 are between 21 and 40, 30 are over 40, and 75 is the total number of root beer drinkers. So, if we look at the total number of root beer drinkers, we find that 75 are these such people. We need to know how many are both over 40 and are root beer drinkers. In this table, the over 40 row is here, and the root beer drinking column is here. We find highlighted in yellow here that there are 30 people who are both over 40 and are root beer drinkers. This is our numerator. 30 over 75 reduces to, as a fraction, 2 over 5. Question 31 is another table, and they're asking a conditional probability. They want to know what's the probability that a flight will arrive on time given that it was an upstate airlines flight. By definition, we need to know the number of upstate airline flights, how many of which of those flights arrive on time and are upstate. They need to be upstate flights. We need to know of the upstate flights, how many also arrive on time. So in question 31, I created a table here to point it out to people that if we look at the upstate row, 43 flights arrived on time, 5 were late, for a total of 48 upstate flights. 48 is the total number of upstate flights. We need to know how many also arrive on time. We need to know how many flights satisfy both criteria. Going back to your table, we see of the upstate flights, 48, we know that 43 also arrived on time. "43 out of 48 is the answer. We could leave this as a fraction or describe it numerically. Question 33 is also another probability question, but 33 also involves the airlines of Podnook and Upstate. But this is not a conditional probability question. They want to know the probability in 33 that the flight is an upstate flight and the flight is on time. We didn't know the number of upstate flights and the ones that are on time out of the total. In 33, we look at the table and find that 33 Podnook flights were on time while 6 were late for a total of 39 flights. 43 upstate flights were on time, 5 were late for a total of 48 flights. If we add the Podnook with the upstate flights, we get 87 total flights. This is our denominator. We need to know how many are both upstate and arrived on time. So if we look at the upstate flights, the upstate row, 43 were on time, 5 were late for a total of 48. The number we're looking for is in blue here because this is where the intersection of the upstate row with the on-time column is, and we find that there's 43 flights that are both upstate and on time. They were upstate and arrived on time. 43 out of 87. Question 35. Question 35 is a conditional probability question. They want to know the probability in this table of selecting a woman given that the person you select is a light smoker. By definition, we need the number of light smokers as a denominator, and we're trying to find, of those light smokers, how many are also women. It is a ratio of the total light smokers to the number that are both women and light smokers. So if we look at the table for question 35, we'll find this first row lists the different type of smokers by the gender of being men or male. We find 550 men in this table. We know that there's the second row here gives me the total number of women and the different types of smokers they could be, for a total of 462 women. But what we need to know is how many are simply light smokers. And the second column is the light smoker column. 83 men, 73 women, with 156 total light smokers. We need to know how many are both women and light smokers. So of the light smokers, how many are women? We look at the light smoker column and find the women row and see that 73 people are both women and light smokers. If we enter this information in our calculator, and we approximate our answer to the nearest thousandths, we see the 7 in the thousandths position. The digit to the right is a 9, which means add 1 to the 7 and get an 8, so that the answer is 0.468.